home to nearly 4 billion people. We all depend on this thin atmosphere for protection. From up here, it's hard to imagine we're in any trouble at all. Back on the ground, it's a different story. While most things are beyond our control, some things we can control. We can make sure automotive exhaust emissions are as low as possible. The United States Congress first passed the Clean Air Act in 1963. Congress amended the law in 1970 to increase restrictions on emissions. The 1990 Clean Air Act has forced automakers to comply with newer, tougher tailpipe emission standards. Hello everyone. Welcome to another Buick Know-How. As you've just seen, we're faced with reducing excessive tailpipe emissions, namely hydrocarbons, carbon monoxide, oxides of nitrogen, carbon dioxide, and oxygen. So we'll discuss each emission and identify the likely sources for repair. This should help you track down some of those more troublesome emission problems. The first exhaust gas to check for is unburned hydrocarbons. Excessive hydrocarbons, or HC as you may know, indicates incomplete combustion. This can be due to basic engine problems, such as vacuum leaks, incorrect ignition timing, ignition system misfire, fuel system misfire, or a faulty or poisoned oxygen sensor or catalytic converter. Many basic engine problems lead to excess HC readings. The mechanical operation of the engine affects hydrocarbon emissions. As the engine runs, it gradually wears. Worn piston rings allow excess blow-by gases into the crankcase, causing excessive oil consumption and contribute to incomplete combustion due to low cylinder pressures. Burned exhaust valves allow unburned fuel into the exhaust stream during the compression and power strokes. Any type of vacuum leak upsets the air-fuel mixture. So, the PCM compensates by injecting more fuel. The technician must locate and repair vacuum leaks. Correct ignition timing is critical to acceptable exhaust emissions. On DIS vehicles, ignition timing is derived from crankshaft position and may or may not be adjustable. However, as timing chain wear occurs, valve timing is affected. Although spark occurs at the right time in relation to the crankshaft, play in the timing chain affects valve timing. As a result, the engine runs as if the timing is incorrect. An ignition misfire is the leading cause of excessive hydrocarbon emissions. Each misfire pumps raw fuel in the exhaust system. The catalytic converter can handle a portion of the fuel, but the vehicle will fail an emission test. Misfire can be caused by fouled, corroded, or burned spark plug electrodes, grounded spark plug wires, or a split spark plug boot. A faulty electronic ignition system can also cause uneven firing. Severe catalytic converter overheating occurs when raw fuel is ignited inside the converter. The intense heat can fuse the catalyst material. The catalytic converter and oxygen sensor must be replaced. What's more important is locating and repairing the cause of the excess fuel problem to prevent its recurrence. A fuel misfire occurs if an injector becomes clogged in an open position. In this case, fuel is constantly sprayed into the cylinder. Injecting too much fuel creates excessive hydrocarbon emissions because an overly rich mixture does not burn efficiently. Clean or replace the leaking injector. The fuel pressure regulator reduces fuel pressure when engine vacuum is high, indicating an idle or steady cruise condition. High engine vacuum pulls the diaphragm to open the return line outlet valve. When the valve is opened, fuel pressure is reduced by routing fuel to the fuel tank. The regulator allows for maximum fuel pressure when engine vacuum is low, indicating heavy acceleration. Low engine vacuum keeps the diaphragm and valve seated against the return line outlet, raising fuel pressure for the higher fuel consumption needs of heavy acceleration. When a fuel pressure regulator fails due to a vacuum leak, the PCM compensates by commanding longer injector on time to deliver fuel for acceleration demands. This results in excessive HC emissions. A fuel injector can have an obstructed spray pattern. The outside tip of the fuel injector can gradually build deposits. Each time the engine is stopped, accumulated fuel on the fuel injector tip dries and then hardens. These deposits are very similar to the formation of intake valve deposits. When a fuel injector deposit becomes large enough, the fuel is sprayed onto the intake manifold walls instead of at the backside of the intake valve and into the cylinder. The engine reacts as though it's losing power, so the driver presses the accelerator further to obtain the desired performance. This causes too much fuel to be injected, and as a result, an increase in hydrocarbon emissions. The oxygen sensor detects the quantity of oxygen in the exhaust stream and provides this information to the PCM in the form of a varying voltage signal. The PCM uses this information to change fuel delivery. The sensor should detect an alternating rich-lean mixture. The oxygen sensor and catalytic converter can be ruined or poisoned by RTV silicone in the combustion chamber or by leaded fuel. A sensor that has this white powdery look has probably been ruined by leaded gasoline. The oxygen sensor and catalytic converter must be replaced. The second exhaust gas to check for is carbon monoxide. The level of carbon monoxide, or CO, in the exhaust indicates combustion efficiency. Very low CO levels indicate a clean burn, where mostly water vapor and carbon dioxide are produced. Low CO levels are desirable. The vast majority of CO is produced by a rich air-fuel mixture at idle, during deceleration, and with a cold engine. The third exhaust gas to check is oxides of nitrogen. Nitrogen monoxide and nitrogen dioxide, or oxides of nitrogen, are often referred to as NOx. NOx is produced by lean mixtures or high combustion temperatures. The exhaust gas recirculation, or EGR system, lowers NOx emissions. EGR routes a small portion of exhaust gas back into the cylinder. Because exhaust gas occupies a small volume, less air-fuel charge is drawn in. With less oxygen, combustion occurs at a lower temperature, reducing NOx. The EGR valve opens and closes to meter exhaust gas flow back into the engine to reduce NOx while not increasing HC or CO. If there is a problem with the EGR system, excessive NOx can be created. Look for EGR valve pintle coking. The digital EGR valve may not be operating properly. A simple vacuum leak can prevent normal EGR operation on older EGR valve and control solenoid systems. An obstructed or malfunctioning cooling system creates excessive NOx. Something as simple as a kinked hose can elevate temperatures. More likely, the problem is a stuck thermostat, a defective water pump, or malfunctioning electric cooling fans. The fourth exhaust gas to check for is carbon dioxide. Carbon dioxide, or CO2, is regarded as the ideal byproduct of combustion. High CO2 measurements indicate peak efficiency and precise fuel control. The fifth exhaust gas to check for is oxygen. While excess oxygen is okay, it really indicates a lean air-fuel mixture. High oxygen readings should be accompanied by higher NOx readings. Now that we've discussed the 5 exhaust gases and their likely sources, let's step through a proven diagnostic strategy to repair emission-failed vehicles. Strategy-based diagnosis can be applied to almost any repair by approaching problems in an organized manner. First, verify the complaint. When diagnosing emission failures, the vehicle may not show any drivability symptoms. Check it out anyway. There is a chance a diagnostic trouble code, or DTC, will help point toward a specific circuit. When you get back, take a close look around the engine compartment. Check for loose electrical grounds, poor electrical connections, and loose, split, or leaking vacuum hoses. Take time to look up relevant bulletins. Addressing a concern with an approved repair may be your answer. A DCS bulletin search is the quickest way to find and print out relevant Buick service bulletins. Doing a bulletin search is easy. Let's go to a local Buick dealership and talk with an expert. How many techs know how to perform a bulletin search from this machine?
Well, we have a shop of 12, and I'd say out of our 12, I'd say 3 to 4 know how to use it really well.
John, I understand that you can perform a bulletin search from this machine.
Yes, I can.
What's the fastest way to find the bulletin that you're looking for?
By either having the VIN number and then going into the system search or the content search.
So, if I brought in a 94 Park Avenue with emission problems and maybe a misfire, what are some key words that we'd use then to put into the machine?
Well, if you go into the system or content search, you could either look it up by misfire or chuggle, or going into emissions or the ignition system.
So basically, you use just a few phrases to describe the way the car's acting, right?
Right, exactly.
There are several ways to access service bulletins. Perhaps the quickest way for Buick technicians is to first select the model year. Then limit the search to Buick bulletins by selecting Buick. Next, select the type of engine or transmission model, depending on whether you are searching for an engine or transmission-related bulletin. In some cases, a body style should be entered, but this may limit search results. When looking for a suspension or brake system bulletin, body style is more important than engine type. An engine or transmission bulletin is probably not specific to only one body style. Finally, the symptom is entered. Bulletin searches may be performed using a T5, T6, T15, T50, T60, or T100 CAMS machine. The monitor displays are similar for each machine. These machines access their CD-ROM drive to search for bulletins. Buick issues monthly CD-ROM updates. Bulletin searches may also be performed using the Dealer Communication System, or DCS link. The DCS equipment is connected via telephone to General Motors Technical Assistance database. Any published Buick service bulletin may be accessed. If there is no bulletin, begin looking at troubleshooting charts for any hints that relate to the condition. Use the emissions report as a guide. If the strategy-based diagnosis didn't turn up anything obvious, you'll need to follow this special emissions flowchart in the know-how manual. This flowchart isolates systems according to the excessive exhaust gas. Let's see, if you have excessive hydrocarbons, the first step is to check for misfire. Misfire is the #1 cause of excessive HC emissions. If you think the misfire is related to one cylinder, perform a power balance test. On 3800 VIN-L or VIN-1 and VIN-K Series 2 engines, use the Tech 1 to identify a weak cylinder. The spark plugs and spark plug wires should be checked for cracks and arcs to ground. The spark plug wires and secondary ignition coil resistance should be checked. Check for low ignition coil voltage output with the ST125 tester. Check Tech 1 readings. Block learn should not be high. Oxygen sensor voltage should vary constantly between 100 and 900 millivolts. The TPS should not be erratic or show dead spots. Perform an injector balance test. Then test each injector's resistance. An injector in a multi-port system with low resistance can rob current from the others in the circuit. Instead of one bad injector, you'd have 3 that don't work. Test the crank sensor for possible signal loss on cylinders 2 or 5. This could be an ignition coil or ignition module problem. Test the cam sensor and magnet for proper adjustment or movement. That pretty much covers the ignition system misfire. Now, let's go on to the next test, checking the exhaust smoke. All engines show visible thin white or gray exhaust smoke after a cold start. When the engine and exhaust system warm up, water from combustion vaporizes to an invisible state. If you still see exhaust smoke when everything's hot, then you've got a problem. Abnormal exhaust smoke is white, blue, or black. Continuous heavy white smoke indicates coolant in the cylinder. These are serious leaks due to insufficient head bolt torque, a cracked cylinder wall or cylinder head, or a blown head or intake manifold gasket. Try a cylinder leak test. Look through the open radiator neck. If you see bubbles, you could be in for a major teardown. Blue smoke indicates excessive oil consumption due to worn piston rings, worn valve guide seals, or a failed PCV valve. Another source is a hole in the shift modulator diaphragm, which allows engine vacuum to pull transaxle fluid into the engine, causing blue smoke. Black smoke indicates an overly rich mixture. Older carbureted vehicles were more prone to this condition than newer fuel-injected vehicles. However, an injected vehicle may have a rich mixture. Visible black exhaust smoke is your clue that a fuel control problem exists. The next test leads you to check ignition timing. The PCM uses a crankshaft or camshaft sensor, or correctly adjusted base ignition timing on engines with distributors to alter spark timing. Next, test the oxygen sensor on a simulated test drive. Be sure to attach an exhaust hose. This test applies to all oxygen sensors. Enter the snapshot mode and select the road test mode. Choose F0 as the trigger point and press F2 for the manual trigger option. Then, select engine coolant temperature. Engine temperature should be around 195 degrees Fahrenheit. Select engine speed and loop status screen. Run the engine at 2500 RPM for 1 minute and then at 2000 RPM to ensure closed loop operation. Select O2S volts while maintaining 2000 RPM. Readings should fluctuate between 100 and 900 millivolts. Select Enter, Exit, or F9 to trigger data storage. Then, either a 0 appears in the corner of the Tech 1 screen or it automatically exits the snapshot mode. Select O2S volts. Use this form from the Know-How manual. Step through each frame of the snapshot and mark once in each of the 4 voltage ranges. There should be 5 marks in Area 1 and Area 4. There should be more marks in Area 1 than in Area 2. Likewise, more marks should be present in Area 4 than in Area 3. Here's what a good sensor reading looks like. Wide, evenly spaced voltage fluctuation means fuel is being modulated correctly. If the sensor modulates narrowly in areas 1 and 2, the air-fuel mixture is very rich, or the sensor is poisoned. If the sensor modulates narrowly in areas 2 and 3, the air-fuel mixture is being modulated correctly, but the sensor is poisoned. If the sensor modulates narrowly in areas 3 and 4, the air-fuel mixture is very lean, or the sensor is poisoned. Block learn, now referred to as long-term fuel trim, is a critical indicator of how much the PCM is compensating to make the vehicle run properly. Fuel trim above 128 means the PCM is running the engine rich. Below 128 means the PCM is running the engine lean. If fuel trim is at 128, but the oxygen sensor readings are incorrect, the oxygen sensor is poisoned and needs replacing. Section 6E3-A contains scan tool data by vehicle, engine, and model year. Toggle through all Tech 1 data to locate any abnormal readings. Tech 1 data is useful to help determine the cause of poor oxygen sensor results. Now let's talk about the air injection reaction, or air system. This is sometimes referred to as a secondary air injection system. The air system injects oxygen into each exhaust manifold to reduce emissions by heating the catalytic converter faster on cold starts and by supplying additional oxygen for hydrocarbon reduction. Diagnosing air systems is detailed in section 6E3-C6, chart C6. If the vehicle failed due to a high NOx reading, perform the EGR system diagnosis found on page 6E3-C7, chart C7 in the appropriate Buick service manual. Investigate anything that could overheat the engine. Now, if you're still looking for the root cause, test the catalytic converter efficiency next. It must be determined whether excessive emissions are due to the engine or to an ineffective catalytic converter. You'll need these special IM240 test tools to perform the rest of the tests in this program. These tools include a 5-gas analyzer, a propane enrichment tool, a purge flow indicator, an EVAP diagnostic station with gas cap adapters, and an ultrasonic leak detector. The purge flow tester and EVAP tester are OBD2 required tools. Use the 5-gas exhaust analyzer, propane enrichment tool, and flow meter first to test the catalytic converter. The exhaust gas analyzer detects how efficiently a preheated catalytic converter changes a known volume of propane gas to acceptable levels of HC and CO. Here's how to do it. Turn the analyzer on and let it warm up. Place the probe fully into the exhaust tailpipe and attach an exhaust hose. On vehicles with dual exhaust, use the included plug kit to stop exhaust flow from the other pipe. Warm the engine to 195 degrees Fahrenheit. Then run it an additional 2.5 minutes to ensure the catalytic converter is fully heated. Now shut off the engine. Disable fuel delivery by removing the fuel pump fuse. Disable the ignition system by removing the fuse or by disconnecting a primary ignition connector. Press the accelerator to the floor and crank the engine for 15 seconds. This clears the engine, exhaust system, and catalytic converter of residual gases. Connect one end of the propane enrichment tool to the propane tank and the other to either the intake manifold PCV connection or to the power brake booster vacuum line. Propane flow rate charts in the know-how manual provide the gas flow rate depending on engine displacement, number of catalytic converters, and proximity of the flow gauge to the engine. If the engine heats the gas, flow rate could be altered. Set the gas analyzer to record the cranking event. With the throttle fully closed, begin cranking and press the push valve to start the propane flow. Crank the engine for 15 seconds. Allow the analyzer to continue recording for an additional 15 seconds. Exit the record mode on the analyzer. Re-enable the fuel and ignition systems. Print the results from the analyzer. Compare them with the pass-fail charts in the know-how manual. If the catalytic converter failed, ask the owner if leaded fuel has ever been used in the vehicle. The owner may not know if leaded fuel was used. If so, replace the catalytic converter and oxygen sensor. If the catalytic converter passed, go on to the Transaxle transmission road test. This next check road tests the transaxle or transmission to see if upshifts and downshifts occur when scheduled. The torque converter clutch must engage and disengage at the proper speed, so bring your Tech 1 along. Part throttle downshifts have scheduled shift points that vary depending on throttle position and vehicle speed. The powertrain should produce acceptable emissions as long as the engine operates in the RPM range intended for a particular gear range. If the transaxle or transmission upshifts sooner than it should, an adjustment may be required. A throttle valve cable adjustment on cars with these cables usually solve this problem. Electronically controlled transaxles and transmissions use the throttle position sensor instead of a TV cable. Incorrect shift timing usually means the throttle position sensor needs adjustment. But verify all shift speeds before adjusting anything. Follow a road test shift speed chart to identify upshift speeds at a 10, 25, 50, and 100% throttle opening. If the TP sensor is adjusted correctly, but the vehicle shifts at the wrong speed, the transaxle or transmission may require further diagnosis to locate the cause of incorrect shift points. We've already seen the 5-gas analyzer in action during the catalytic converter test. Now, let's check out the EVAP and Purge flow test equipment. The EVAP diagnostic station includes the EVAP tester, cap adapter kit, and ultrasonic leak detector. The EVAP tester pressurizes the EVAP system so that the technician can use the leak detector to pinpoint the leak. Here's how the EVAP system test works. Like most tests, it starts with a visual inspection. Look for split hoses or broken components. Inspect the system for any signs of tampering. Repair these systems to OEM status. Select and install the proper gas filler cap adapter to the vehicle. Attach the nitrogen tank to the filler cap adapter. Clamp the fuel tank vapor line at the canister to seal the system during the test. Route the station vent hose into the exhaust collection hose. Set the selector switch to pressure and bring the system up to 14.5 inches of water. Set the selector switch to hold. If the gauge shows at least 8 inches of water pressure after 2 minutes, the system is okay. If not, then continue testing. Fuel tanks larger than 25 gallons require more nitrogen gas to reach the required test pressure. Also, these larger EVAP systems may require more than 2 minutes to leak down to 8 inches of water. If the system leaks below 8 inches of water, set the selector control to pressure again and raise the pressure to 30 inches of water. Raising the pressure helps locate the leak. Check the gas cap for leaks with the ultrasonic leak detector. If it leaks, replace it. If it's okay, leak check the entire system with the ultrasonic leak detector, starting at the filler neck. If the leak cannot be found, drop the fuel tank. Check the top of the tank, the vent lines, the fuel pump output and return lines, and the pump access port for leaks. Make the necessary repairs to correct the leak. The Purge flow test equipment detects problems with the canister purge system. This test is designed to identify failed canister purge flow components for repair. Verify proper routing of all vacuum hoses according to the vehicle emissions control label. Correct misrouted vacuum hoses. Replace cracked or split vacuum hoses. Identify the vehicle's EVAP system configuration. Buick has used 3 configurations since 1990. This Park Avenue uses an integral purge valve solenoid. Connect the purge flow indicator in the purge line. Start the engine and warm it up to about 195 degrees Fahrenheit. Then raise the engine speed to 2,500 to 3,000 RPM for 15 seconds. The purge flow indicator should read a flow of at least 10 liters per minute. If the flow meter reading is okay, you're through. If it's not okay, continue testing. Disconnect the meter from the purge hose. Raise engine speed to 2,500 to 3,000 RPM for 15 seconds. The purge flow indicator should read a flow of at least 10 liters per minute. If the system now reads okay, you're finished. If you're still not getting enough flow, there's probably not enough vacuum from the purge hose. After that's repaired, reconnect the purge hose. Disconnect the solenoid connector. Momentarily energize the solenoid using the fused jumper. Once again, raise engine speed to 2,500 to 3,000 RPM for 15 seconds. The purge flow indicator should read a flow of at least 10 liters per minute. If the flow is 10 or more, the system is okay. If not, the purge solenoid, valve, or canister may be restricted. Now that we've discussed emission sources, diagnosis, and repair, I'd like to take a few minutes and talk about IM 240 emission testing. IM means inspection and maintenance, and 240 means the test lasts 240 seconds. IM 240 tests emissions and assigns a pass or fail grade for any vehicle built since 1968. Oh, incidentally, IM 240 and OBD2 are not related. The test includes an evaporative or EVAP system leak test, a canister purge flow test, and a two-stage dynamometer loaded drive cycle test. But before the vehicle is actually tested, the tires, exhaust system, and cooling system are checked. Once the vehicle passes the initial checks, the EVAP system sealing integrity is tested. Then the fuel system is pressurized to about 0.5 psi and monitored for 2 minutes. The system passes the test if it holds at least 0.3 psi. The canister purge flow test ensures that the engine is regularly drawing accumulated fuel vapors from the charcoal canister. A flow meter is temporarily installed between the charcoal canister and the intake manifold. After the test equipment is in place, the test driver accelerates, maintains specified cruise speeds, and brakes the vehicle to follow the trace pattern. This places the vehicle in a true stop-and-go city driving environment. Exhaust gases are analyzed each second. It stands to reason that you'll only be seeing Buicks that did not pass its emission test. Emissions diagnosis and repair. It's a tough business, and it can get a little daunting with these new test reports. But if you think it over, drivability technicians have been handling these types of problems for years. IM 240 and emissions repair. It's just a new slant on things you already know. Piece of cake. See you next time.